Today's lesson is on the law of cosines. Our objective for today is to solve oblique triangles, side angle side, and side 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 type of triangles utilizing the law of cosines. As a quick review, the law of sines is used to solve oblique triangles of case 1 or case 2. That's side angle angle or angle side angle. Case 2 is side side angle. It's the ambiguous case. Remember, with case 2, you have to check for one triangle, two triangles, or no triangles. Case 3 is side angle side, and case 4 is side side side. Case 3 is when we know two sides and the included angle, and case 4 is when we know all three sides. These two cases use the law of cosines. The theorem for the law of cosines says that for a triangle with sides A, B, and C and opposite angles alpha, beta, and gamma respectively, then c squared equals a squared plus b squared minus 2ab times the cosine of gamma. And b squared equals a squared plus c squared minus 2ac times the cosine of beta. And a squared equals b squared plus c squared minus 2bc times the cosine of alpha. Now these may look a little bit complicated to start with, but hopefully after I show you the pattern it won't be too bad. If I am looking for c, then I must use the form of the law of cosines that starts with the c squared. And I'm going to take the other two sides of the triangle, square them, and add them together. So if I'm looking for c squared, I'm going to take a squared plus b squared. If I'm looking for b squared, I'm going to take a squared plus c squared. That's the other two sides of the triangles, square them and add them together. And if I'm looking for a squared, I'm going to take b squared plus c squared. Every single one of these forms has a minus sign next, and it's minus 2. Every single one of them has minus 2. Then we're going to take the two sides that we just squared and added together, a and b in this case, and multiply them together. A and c in this case, and multiply them together. B and c in this case, and multiply them together. So we took the two sides that we squared and added and multiplied them times the 2. Then you're going to multiply by the cosine of the angle that is opposite what you're looking for. So gamma is opposite c. So in the first one we're going to multiply by the cosine of gamma. Beta is opposite b. So in the second one we're going to be multiplying by the cosine of beta. And alpha is opposite a, so in the third one we're going to be multiplying by the cosine of alpha. And now you should have all of those memorized. So let's look at an example. Let me slide this up just a little, and we're going to be using this formula, this form of the law of cosines, so I'll leave it here. It says solve the triangle if I know that b is 3, c is 4, and alpha is 40 degrees. This is a side angle side triangle. So we do not know what side A is, so that's what we're going to look for first, is we're going to look for side A. So a squared is equal to b squared, which is 3, so that's 3 squared, plus c squared, which is 4 squared, minus 2 times b times c times the cosine of alpha, which is 40 degrees. So all I have done is substitute in the numbers that I knew into my formula. And now all I have to do is go to my calculator and type in 3 squared plus 4 squared minus 2 times 3 times 4 times the cosine of 40 degrees, being sure that I'm in degree mode, and it will tell me then that a squared is approximately 6.61493365, and that goes on and on. Then I'm going to take the square root of that answer to get a is approximately 2.57 units. So now I know side A. The next thing that I'm going to do is I'm going to look for, I personally chose to look for angle beta. You could have looked for angle gamma if you wanted to. So I'm going to use this second formula the b squared equals a squared plus c squared minus 2ac times the cosine of beta. And what I need to find is beta, so I'm going to solve this for the cosine of beta. So I'm going to take the a squared and subtract it over, b squared minus a squared minus c squared. And that's going to equal negative 2ac times the cosine of beta. I want to solve for the cosine of beta, so I'm going to divide everything by negative 2ac, negative 2ac. And when I do that on this side, everything cancels, and all I have here is the cosine of beta. And on the other side, when I take b squared divided by negative 2a, that's going to give me negative b squared. The negative divided by negative is the positive a squared. C squared, negative c squared divided by negative 2 is positive c squared. All of that over 2ac. I left my c out there. I apologize. Now, you don't have to do that every time because I'm going to teach you real quickly how to come up with these formulas. Okay, so I want you to watch this very carefully. I want you to see that the cosine of beta is equal to the two sides that are not opposite beta, a and c, added together and squared just like before, minus the side that is opposite beta, divided by 2ac. For the cosine of gamma, it would be the two sides that are not opposite gamma. That'd be a squared plus b squared minus, I'm off the page, minus the side that is opposite gamma, which would be minus c squared, divided by 2ab. And then the last one, which would be the cosine of alpha, would be the two sides that are not opposite alpha, so that would be b squared plus c squared, minus the side squared that is opposite alpha over 2bc. And you'll be able to find every time using those formulas one of the angles. Okay, so remember that as I slide back up here, what we were going to do next was look for the cosine of beta. So I'm going to use this formula right here for the cosine of beta. So the cosine of beta is going to equal a squared, which is 2.57 squared, which we already know what that is because we found it right here earlier, plus c squared, which in this case is 4, minus b squared, which in this case is 3. So 3 squared, scooch, scooch, over 2.57 times 4 times the 2. So 2ac. Okay, then all we have to do is put that into our calculator, and that gives me approximately 0.6622, and then take the cosine inverse to find beta. Is the cosine inverse of 0.6622, and that tells me then that beta is approximately 48.5 degrees. So now I have alpha, and I'm sorry, this is not alpha, this is A, side A, and angle beta. Now, to find the last angle, which is angle gamma, you can see from the slide that all we have to do is take 180 degrees and subtract the two angles that we already know, which would be alpha, which is 40 degrees, minus beta, which is 48.5 degrees, to find out that gamma is 91.5 degrees. And now we have solved that triangle. Okay, the next example is solving a triangle when we know all three sides. Side, side, side. So in this case, we know that A is 3. We know that B is 5. And we know that C is 7. And this is side, side, side. So what we're going to do first is find one of the angles. Okay, I'm going to look for the cosine of alpha to start with. And we talked about a few minutes ago that we could use this form of the law of cosines, that the cosine of alpha is going to be the sum of the squares of the two sides that are not opposite alpha, so b squared plus c squared, minus the side that is opposite alpha, so minus a squared, divided by 2 times b times c. So these two are multiplied by 2, and that's what we're going to divide by. So now we can say, well, the cosine of alpha in this case is going to be 5 squared plus 7 squared minus 3 squared over 2 times 5 times 7. And then we're going to take that to the calculator. And if we take that to the calculator, we get the cosine of alpha is equal to 65 over 70, which is the same as 13 over 14, just squaring and adding and multiplying. And then we're going to do the cosine inverse. So alpha is equal to the cosine inverse of 13 over 14. So alpha is equal to 21.8 degrees. Now we're going to find a second angle. So I'm going to slide over this way. And now we're going to actually, will you be able to see that if I slide it right there? I'm going to find now beta. So I'm going to use the cosine of beta is equal to a squared plus c squared, because those are the two sides that are not opposite beta, minus b squared over 2 times a times c. So the cosine of beta is going to be 3 squared, because a is 3, plus 7 squared minus 5 squared over 2 times 3 times 7. And when we multiply that out, we find that the cosine of beta is going to equal 33 over 42, which reduces to 11 over 14. And then we're going to take the cosine inverse to find beta. Beta is equal to the cosine inverse of 11/14. So beta then gives me approximately 38.2 degrees. And then to find gamma, we're just going to subtract. So to find gamma, we're going to do 180 degrees minus 21.8 for alpha minus 38.2 for beta, and that tells me then that gamma is approximately 120 degrees. Okay, that does it for today's lesson. I hope this has helped. Come prepared with questions.